So, calculus. This is the last one I have to do today, I think. Calculus. I haven't gotten anything about whether or not you have questions on the homework that I assigned on Tuesday. So that would be on position, velocity, and acceleration. Again, if you're having problems, what I really want you to do is I want you to upload those answers as soon as you can. I'm actually recording this probably about 3 o'clock on Tuesday, and I haven't received any yet. At least one of you have messaged me saying you're working on it, which is great. That's fine. But if you can, just upload them. I just don't want them at 3 a.m., okay? I'm sleeping. But if you do find you're running into problems, then please just let me know when they're done. Just upload them to me so that I can see that they're done. You can check the answers and see if they're right or wrong, so you know whether you're doing it right or not. But I just need to see that it's done, that you're actually doing something. I don't think you guys are home playing Fortnite, but just in case. So we're actually this video is going to cover section 4.7. Again, if you have problems back in section 4.6, I'll make a video on that. So we have to talk a little bit about what section 4.7 is on and some of the language they're going to use in there. Section 4.7, the way they label it, I don't like it. They call it rates of change in the social sciences. It really should be rates of change in the business world. It's really talking about business, and it's talking about how those first and second derivatives that we applied to position, velocity, and acceleration, how they apply in the business world. So we have to talk about some of the terms that they're going to be using, otherwise you won't know what's going on. So the first thing is X. Whenever they talk about X, it's always talking about the number of items sold, or the number of items that they make and they want to sell. But it's always talking about the number of things that are being sold. So if my business is selling t-shirts, then X is the number of t-shirts that I have to sell. And then we have little p. Little p. Little p stands for price, or sometimes in the business world, instead of calling it price, they call it demand. But it really is the formula for figuring out the price at which you're going to sell your stuff. So again, going back to the t-shirt example, if I'm selling t-shirts, at what price am I going to sell those t-shirts at? In that, figuring out that formula, the formula that applies to that is called the price or the demand formula. Hi, do you want to be in the video? Come here. Come here. Rolly wanted to pop in and say hi. Well, obviously he kind of doesn't, but there he is. Rolly's saying hi. Putting him down. All right. Bless you. Oh, good. Now you're coughing. I did not try and kill you. Okay. So price. The next one is, and by the way, you don't have to come up with that formula. It will be given to you. Whatever that is, it will be given to you. Another one is R at X, which stands for revenue. Revenue is the amount of money that's coming in. It's not your profit. Profit is different. Profit is when you have the amount of money coming in after you've paid all your bills out of that. That's the profit. That's the money you get to keep and put in your pocket. Revenue is just the money coming in. So if I sell 20 t-shirts at $10, my revenue is $200. Revenue, there's a way to figure that out, and that is the number of items sold, which would be X, because X is the number of items sold, times your price formula. So it's the number of items sold times your price. So again, if I had 20 t-shirts and I sold them at $10, 20 would be my X because I had 20 of them. My price would be $10, so that would be 20 times 10. So for revenue, you very likely will have to come up with a formula yourself. Another one is is C at X, which stands for cost. Costs are those things that you incur that you have to pay. So if I'm going to sell my t-shirts, first I have to buy the t-shirts from someone who makes them. I might have to pay rent on the place, on my store. I might have to pay employees. I'll have to pay electricity to keep the lights on. All those things that you have to pay for that comes out of your revenue, those are your costs. This formula will be given to you. There's no way to figure it out. It's going to be given to you. The last one is a capital P instead of a small p, and that stands for profit. And that's the money that you actually get to keep, put in your pocket, take home. That's the money you get to live off of. There is a way to figure profit out. You take your revenue, which is the money coming in. So you take your revenue formula and you subtract your cost formula, all those bills that you have to pay. Whatever money you have left over, that is your profit. So if you do revenue minus cost and you get a positive, that means there's money and you get to keep it, and that's your profit. If when you do revenue minus cost you get a negative, that means your business is in trouble and you're having problems because you're not making any money. Now, whenever you see the word marginal in terms of business, whenever you see the words marginal in front of these, so marginal price, marginal revenue, marginal cost, marginal profit, it really means the rate of change of that thing. So it means the rate of change of your revenue. How quickly is that revenue changing? Because likely the more that you sell, the more revenue you'll get. That makes sense, right? But how quickly is that changing? Because your profit, your rate of change of profit, that can change dramatically because so if I'm a t-shirt and I'm only selling 10 t-shirts, it's going to cost me a lot to first buy those t-shirts. But if I'm going somewhere and I'm saying, listen, I'm going to buy 5,000 t-shirts from you so I can go and sell them, I'm going to get a better deal on those 5,000 so they don't cost me very much per unit. So whenever you see the word marginal, it means rate of change. And we know that in calculus, whenever you see the word rate of change, it means you're going to do the derivative. So whenever you see the word marginal, it just means that you're going to do the derivative of that thing. We're going to do 3 examples. Example 1 is quite simple. Example 3 is pretty straightforward. Example 2 is the one that's going to take us a little bit longer. I'm going to try and do it as quickly as possible. So again, there are all the terms that you're going to see. Price will be given, cost will be given. You may have to figure out revenue and profit. So, looking at example number 1, I'm on page 245 in your textbook. I hope you have that home with you. On page 245 in your textbook, it says that there's a company that manufactures tires for kinds of bikes. Very boring, but sorry. My husband is downstairs making noise. This is great. The owner of the company uses regression. You don't need to know what that is. That's a business term. To estimate the cost in dollars of production of a certain tire for their top selling mountain bike to be. So the cost formula, so they're saying some business analyst has done this process called regression, and they have figured out that the formula for the cost of making these tires is $4,930 plus 8.4x, and remember x is always the number of things that I sell, minus 0.0006. I think it's an x squared. Let me look at that again. Yep. And they're saying that this is valid. This formula works from a production level of anywhere from 0 tires to 2,000 tires. So after that, something changes, either maybe the materials to make the tires get cheaper, something happens after that 2000 level, and that formula wouldn't apply anymore. So that formula only applies to 0 to 2000. So the question that they ask in part A is find the marginal cost at a production level of 500 tires. So because they use the word marginal, that means I'm going to do the derivative. So to do the derivative, that is 0. This is 8.4 minus, I'm going to bring the 2 down, I'm going to multiply it by 0.006, and that's going to give me 0.0012x. Decrease your exponent by 1. Now, they said find the marginal cost for 500 tires. So I'm just going to put in 500 as my x, because that's the number of tires I'm going to make. When they figure it out, it's 7.8. So what that is telling you in real life is that the marginal cost is $7.08. So it's $7.08 per tire. So it's costing me $7.08 per tire. That is the rate of change at a production level of 500 tires. Then they say find the actual cost, so no marginal in that sentence. Find the actual cost of producing the 501st tire. So instead of using the marginal, we're going to use the cost formula, because they didn't ask about what is the marginal cost. They said what is the cost at making the 501st tire. And what we're going to do is we're going to figure out the cost of making 501 tires, and we're going to figure out the cost to make 500 tires, and we will subtract them. What that will tell us is, what did it cost to make that one 501st tire, the 501st tire coming off the assembly line? What did it cost me to make that? And it should be really, really, really close to this number, by the way. So what I'm going to do is I'm going to take my cost formula, 4,930 plus 8.4, and I'm going to put 501 in there, minus 0.0006 times 501 squared, minus, and again I'm subtracting everything from this point. I'm going to do the cost formula again, but this time I'm putting 500 in as my value. So times 500 minus 0.0006 times 500 squared. And so I'm going to do this. I'm going to subtract this. It works out to be 7.79, and it keeps on going. But what that means is it is just ever so slightly less to produce the 501st tire than it is at the production level of 500, meaning every time I make a tire, the cost of that tire goes down just slightly. So it's 7.79, but a whole lot easier to do this than it is to do this. All right. Sorry, dog's barking. Welcome to my world. So that's example number 1. That's all it is. There you go. I keep forgetting I don't actually have to give you time to copy stuff down, because you can just hit pause. You're going to not want to come back to class. You're going to want to learn this way all the time, because then you can just hit pause on me whenever you want, or turn the volume off on me. So example number 2 is a lot more involved, only because the difficulty level goes up because they start putting fractions in it. We're going to skip part A and B. We're not going to bother with that because I'm never going to ask you questions like that. So we're just going to skip it. But you have to know. So there's a popular ice cream parlor. They give it a name. Maybe we'll call it King's. I don't know. They have performed a market survey. Just a sec. There we go. And it shows that the yearly demand for milkshakes, remember, demand, price, same thing, The yearly demand is 500,000 minus X over 100,000. So little p for price or demand, same thing. It's an interchangeable word in economics. Is 500,000 X minus X, over 100,000. That is the formula for figuring out the price. P is the price in dollars. X is the number of milkshakes that they make every year. So again, part A says graph this. So you would have to like make up values for X. Like if I sell 10 per year, if I sell 100 per year, and put it in here and get a little table of values and graph it. We're not going to do that. And then it wants you to actually determine the quantity of milkshakes that go with the price of $0, of $1, of $2, of $3. Again, if you wanted to do that mathematically, you'd have to put the price $3 in here and solve for X. We're not going to do that. Where we are going is to part C. Part C says find the marginal revenue at a production level of 2,000 milkshakes per year. So it wants a marginal revenue. Well, we don't have a revenue formula, but remember that I said revenue is the number that I sell times the price. So my revenue would be the number that I sell times the price. That would be the revenue. So if I expand that out, that would be 500,000 X. Did I put enough zeros in there? I think so. Maybe I put too many. No, I put the right amount. Minus X squared all over 100,000. Now, the textbook does the derivative slightly differently than I'm going to do it. They actually take out 1 over 100,000 as a common factor, and they leave 500,000 X minus X squared in a bracket. And then what they don't show that they do, but they actually do, is they do the product rule with it. We're just going to go ahead and do the quotient rule with this because we have a fraction anyway. So remember that the quotient rule says G F prime minus F G prime over G squared. That's what the quotient rule says. So if I want to find the derivative of this, first G, remember G is always your denominator, which is 100,000, times the derivative of this. Well, the derivative of F, which would be the top, would be 500,000 minus 2x. Now, here's where life gets a little easy. So minus F, which is 500,000. Some of you are seeing where this is going already. Minus x squared. And then the derivative of G, but the derivative of 100,000 is just 0. So all of that is just gone because you're multiplying it by nothing. And that's all over 100,000 squared. Well, if I have 100,000 times this over 100,000 squared, I can actually cancel this 100,000 with one of these 100,000 because I put two of them down there. And so I have 500,000 minus 2x all over 100,000. So now that's my derivative. I can't really simplify that anymore. I mean, I could take out a common factor, but there's no point. They want to know what is the marginal revenue when I make 200,000 milkshakes per year. So I'm just going to take, and I'm going to do 500,000 minus 2 times 200,000. So if I do my math right, that would be 400,000 all over 100,000. I did not put enough zeros. 100,000. And so if I do the math right, and I'm doing it in my head, although I just cheated and looked in the book to be sure I'd done it in my head right. This is 500,000 minus 400,000, which is 100,000, divided by 100,000, that is 1. So what that means is that my revenue, the amount of money coming in, if I make 200,000 milkshakes per year, my revenue, my money coming in is increasing at a rate of $1 per milkshake. And there go my dogs again. So that's what that is saying, okay? So it says it represents the approximate additional income to the company per additional item sold. So it doesn't mean that they're selling their milkshakes for $1 and they're getting a revenue of $1 per milkshake. It means it's increasing by $1 at that point. So if before they were making $6 on a milkshake, if that's the revenue that was coming in, now they're going to make $7 because it's the rate of revenue is increasing by $1 per milkshake. Okay, so that's part C because we skipped A and B. Part D. I'm going to erase this. Part D. I might need that up there, so I'm going to keep that part right there. What the revenue formula is, because that's the revenue formula. So part D says, so they estimate that the cost, and remember I said they will always give you the cost formula if you need it. It's not something you have to figure out. It's given to you. So the cost formula is 220,000 plus 0.63x. 220,000 plus 0.63x. Can you imagine if this is your job? You're a business analyst and your job is to go out and figure out what formulas apply. Like, what is the formula that applies to figuring out what the cost is? I would not want that job. So that is the cost. So the question says, calculate the profit and the marginal profit. So again, as soon as you see that word marginal, you know you have to do the derivative. So figure out the profit and the marginal profit for 300,000 milkshakes per year. And then they want you to talk about what that means. In other words, they just want you to explain in real life what that actually means. So we'll talk about that when we get there. So first off, we have to figure out profit. Profit, remember, is revenue, the money coming in, minus the cost. So it's 500,000 minus x squared over 100,000 minus the cost, 220,000 plus 0.63x. That's what they do, that's the cost. So at this point, if you want to, you can put in exactly 300,000 to figure out your profit. So you could put 300,000 in for your x. So 500,000 minus 300,000 squared divided by 100,000 minus 220,000 plus 0.63 times 300,000. You could do that. I'm going to let you do that, or not. But I'm going to tell you that the profit for that would be $191,000. So what that says is if they are able to sell 300,000 milkshakes in a year, the profit from that will be 191,000, which sounds really, really, really good. It sounds wonderful. If I could make 191,000, I'd be really happy. But a business analyst's job is to not just look at what this would be, which is a surface number, but actually do some investigation to see, okay, yeah, that sounds great, but what is really going on here? And part of finding out what really is going on here is looking at the marginal profit, looking at the rate of change of the profit. So in order to do that, we would have to do the derivative. Now that is not going to be fun. What you can do is you can simplify this a little bit. Let me show you what I mean by simplify this a little bit. This is 500,000 over this minus x squared over this. The 100,000 is a common factor. It's the same for both. So 500,000 over 100,000 is really just 5. Oh, sorry, it's 500,000x. My apologies. So if I have 500,000x over 100,000, that's really just 5x minus x squared over 100,000 minus 220,000 minus 0.63x. So I can simplify that even more because I have two like terms here. So I can do 5 minus 0.63. They don't do this in the textbook. Whoops, sorry, I hit the piano. They don't do this in the textbook, so I have to do it on my calculator. So minus, they do it slightly differently. So I would have 4.37x minus x squared over 100,000 minus 220,000. And so all I've done is I've simplified my profit formula. They want to know the marginal profit. So I have to do the derivative of this. So to do the derivative of this, the derivative of 4.37x, I'll put it over here, the derivative of 4.37x would just be 4.37. Again, I just brought the 1 down, multiplied it by 0.37, and decreased my exponent by 1. Here, if I bring the 2 down, I really have 2 over 100,000. You can write that formula, or you can reduce it. 2 over 100,000 would be 1 over 50,000. So it would be minus x, because again, I decreased my exponent by 1, over 50,000, because I did 2 divided by 100,000. And then the derivative of 220,000 would be 0, because always the derivative of a constant is 0. And so to figure out the marginal profit at 300,000, I just put 300,000 in here for my x. So if I do that, if I do 300,000 divided by 50,000, it gives me 6. So if I do 4.37 minus 6, I actually give negative 1.63. Because that's a negative, what that's saying is you are starting to lose profit. Your profit margins are going down. It's not that you're losing $1.63 per milkshake. Well, actually it is. You are starting to lose money. Your profit is going down by $1.63 per milkshake at that point. So they've gone past what would be the optimal price to sell it at. They're probably selling it at too high a price, or their costs are too much. But they're starting their profit, whatever their profit is, it's starting to go down. So if you were to figure out what's their profit here using this profit formula, remember we figured out that their profit was 191,000 at 300,000. If you were to put in a bigger number than that, like 400,000, sorry, just a second. If you were to have a bigger number like 400,000, then the profit wouldn't be 191,000. It'd be less than that, because their rate of change of their profit is actually decreasing. That's what that means. Okay, so a negative rate of change means that that is going down, and that's not good. Last example is example number 3 on page 248. Where did I put my eraser? There it is. Even in this little space, I can lose stuff. So example number 3 on page 248. This is the last one we have to do. And then when I post this, again, I'll have questions with it. Please do the questions and upload them to me. If you have questions, let me know so I can go back and do them. So it says the predicted population of a small town is modeled using the formula. So this is kind of leaving the business end of it and going to the engineering end of it. This would be a civil engineer's job. So they're saying that the population, based on the number of years, is 950 plus 2t plus, no, sorry, minus 100t to the negative 1. That's the formula. So again, someone somewhere came up with that formula, and I think I wrote it down wrong. Yeah, it's 20t. So that's the formula that this wonderful civil engineer came up with to figure out what will be the population of this community in a given amount of time based on what it currently is. So it says in part A, what is the rate of change of the population after 5 years? So again, because they say the words rate of change, that automatically means that you're going to be doing the derivative. So the first thing I'm going to do is I'm going to do the derivative for the population formula. So the derivative of 950 is nothing. The derivative of 20t is 20. The derivative here, I'm going to bring my 1 down, so it's going to make it positive 100. But here's where people mess this up. If I decrease my exponent by 1, that becomes t to the negative 2. If you don't like negative exponents, you can write that as 100 over t squared. Same thing. It doesn't matter whether you write it this way or this way. Your calculator will do negative exponents, or you can do 100 divided by t squared. It won't make any difference. So they want to know what is the rate of change of this community after 5 years. So that means for t, we're going to put in 5. So if I do 20 plus 100 over 5 squared, then that is 20 plus, well, 5 squared is 25. 100 divided by 25 is 4. So that is 24. So again, keep in mind what they're talking about when they talk about rate of change. That doesn't mean that there's 24 people in the community. It means that the rate of change, because it's positive, it means the population is increasing, and it's increasing by 24 people per year. So obviously people are moving into this community because the population is increasing, or people